I'm Rob Higuerita, and I'm an enterprise support lead at AWS, and I'm based out of Austin, Texas. Welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS support. Joining me today is Luis Fox and Hugo Adao from AWS. Can you give us a quick introduction, Luis and Hugo?
Sure. Hi, everybody. My name is Louise, and I'm a technical account manager based in Amsterdam in the Netherlands, where I work with a diverse range of customers on many different types of AWS services, including S3. So happy to be here.
Hi, hello, my name is Hugo. I'm a senior cloud support engineer. I'm located in Dublin. I support customers. I'm from the storage and content delivery team, where we support customers using those same services.
Thank you for the intro. So on today's episode, we're going to be focusing on how AWS supports you in S3 security features and support best practices as well. So before we get into the details, a quick note to the attendees online. Please feel free to use that chat window on the right-hand side of your screen to share your thoughts and ask your questions throughout the episode. We really look forward to your questions and from hearing from you. Luis, can you start us off and walk us through what we're going to be talking about today?
Yeah, thanks, Rob. So today we are going to be starting with access controls. So we'll be going through different types of ways to restrict access to your bucket, bucket policies, IAM identity-based policies, ACLs, and service control policies as well. We'll be talking about block public access, so providing control to ensure basically who has access to your objects and making sure it's never public where possible. Access points, so simplifying managing your data access at scale for applications using shared data sets on S3. S3 encryption options, so encrypting your data in transit and also at rest. Pre-signed URLs, so granting temporary access at a specific S3 object. Access analyzer for S3, so this would be reviewing bucket access. Logging and monitoring, we'll be going through the different services here that are integrated with S3 and which would best suit your use case for that kind of thing. Compliance, and then also security best practices from myself and Hugo for S3. So starting off with access controls. So there's three different types of access controls for S3. The first one being bucket policies. IAM first. So this would be identity-based policies that you can configure policies for your IAM users and roles to set what buckets or objects they're authorized to use, or access. S3 bucket policies, these would be resource-based policies where you can grant who has access to specific buckets. And lastly, S3 access control lists, also called ACLs, where you can specify more granular access for who has control to your objects or buckets as well. So starting off, we're going to do some examples on bucket policies. So this would be the general structure of a resource-based bucket policy. You have your version, you have statement. Optional is a statement ID. Here it says public read. And then the effect can either be allow or deny. So in this case, it's an allow policy, the principal being everyone. And then there's two actions that are granted, which are two different S3 APIs, get object and get object version. And then the resource, you're going to be specifying the bucket, and the /* is the objects within the bucket. So what this policy here is doing is saying get object for anybody. That could be anonymous users, anyone on the internet, to that example bucket. So this is granting read-only permissions to anyone. So it's basically making your bucket public read. The next example here is limiting access to specific IP addresses. So what the first statement is doing is it's again allowing the public read. So it's allowing anyone access to the objects within your bucket. However, then the second statement is denying all access to all principals for all S3 APIs, unless the request is made from or not made from this exact source IP address. So that kind of restricts access and limits the access to your bucket basically to only this IP address. And this can also be done with a different condition like VPC endpoints as well. Then this bucket policy here is granting permission to an Amazon CloudFront origin access identity. So this is a special type of user that you can create where you can then specify this user in the principal field And what it's going to do is it's going to allow any request to not go directly to S3, but instead they will have to go through your CloudFront distribution. So it's just an added bit of security again, where no direct request can be made to your bucket. So what you're doing here is you're granting get object to your example bucket for only the CloudFront origin access identity. So that's going to be the only user that can actually access the bucket. So your users will have to go through your CloudFront distribution to access it. Moving on to access control lists. So access control lists are, it's a way to manage access to your buckets and objects. So each bucket and object has an ACL attached to it as a sub-resource, and it defines which AWS accounts or groups are granted what type of access. So as you can see in the table here, this summarizes all of the ACL permissions, and you can see that they're different when they're granted on a bucket or when they're granted on an object. So that's because bucket and object ACLs are actually independent of each other. So specifying different access, basically. For example, an object would not inherit the permissions from its bucket. So here's the list of them all: read, write, read ACP, write ACP, and full control. And just from a security perspective, we would never really recommend granting full control on the bucket, obviously. Moving on to boundary enforcement, I think is the next slide. Yeah, Hugo,
Yes.
take it away.
Yeah, thank you, Louise. Boundary enforcing, Louise was talking about how you can prevent access to your bucket using ACLs or bucket policies, but there is also other ways for you to enforce that boundary on your S3 bucket. What happens also is that by default, and remember, when you create an S3 bucket, the bucket is private, so that means that all public access is denied. And here, where we have this special feature that is S3 block public access, it's a feature that if in the event that you mistakenly create either a bucket policy or an ACL that grants more than you wish, this feature will block that and will override that. Another boundary enforcement that you can use is the AWS organization service control policies. Let's say that you have an organization, and on your organization you have several accounts, and you want to have a unique policy for all your accounts without going to individual accounts and specify each policy. So it's one place you can push that, let's say, policy across all the accounts. The next one will be the Amazon S3 VPC endpoint policy. If you have like a private VPC and you want to allow access to S3, but not allow access to anything else, you can use that. It will create like a tunnel between your private VPC and S3 and allow your instance, your users to access S3. So let's talk a bit more about S3 block public access. So there are 4 security settings. You can deny or you can override either ACLs. You can create or deny the creation of new public read ACLs. Same goes for bucket policies. If you already have an existing bucket policy, it will override and start to ignore, or you can also deny the creation of new bucket policies that allow public reads. So they are applicable at the account level or individual buckets. If you have a need to have buckets that they need to be public, you can implement that. And at the same time, you can also implement a bucket level that will deny that. And lately, like we mentioned, you have the possibility on the organization level to implement also that change. Let's say that you know that for sure on your organization, there is no requirement for you to have public read buckets. You can use that at an organization level. So that means that any bucket existing or new buckets that will be created will have the possibility to be public. It's a great feature to block any mistakenly created policies that will allow access to data that you should or you don't want to, especially when you're dealing with confidential data. Here we have an idea of what you will see on the console. In this particular case, is for the account level. And as you can see, we have the block for all, and we'll block all four options, either grant through new ACL. So if you try to create a new ACL, it will deny, or you can only apply to existing ACLs. So let's say that you have a bucket with millions of objects, and you want those millions of objects have an ACL that allow public reads. You can apply this, and automatically S3 will start to, let's say, ignore that public read ACL, and your objects become private. The same goes for the bucket level, either a bucket policy to deny new public buckets or to ignore existing ones. Not sure if we have any questions so far.
Yes, we do have some today. One of our questions coming from the spec 007, back on the ACLs topic. Can we replace the permissions on S3 objects in bulk?
No. So what happens here is that ACL for object level are per object. There is no way for you to, on a single click, apply ACL to all objects. No. You will need to apply to each individual object. So let's say if you have 100 objects on your bucket, you will need to go through all 100 objects and apply that ACL into that object. The recommended way here is to use bucket policies, because in a single point, you can just apply, let me create a bucket policy, and for that prefix or for all those objects, I want to grant get access, anonymous get access. So in that single point, you can grant exactly what you want to apply a public read ACL to all the objects.
All right, thanks, Hugo. Appreciate that.
Welcome.
We do have one more that I'm not sure I'll have an answer for from Mike Adam 123. How can I get from one S3 object all the attributes such as tags and URI while the S3 API does expose them? Is there another way to potentially get that?
No. So the only way for you to get that information is to use the public APIs, and you will need access to get that. For example, by doing the get the head object. When you do a head object, you will see all the, let's say, information of the object without downloading them. And if the object contains tags, contains metadata, you will also see it. But other than that, no. Because what happens is that several features, they will require you to do several API calls. The head object will return, for example, the object attributes plus the metadata. But if you want to get a tag for an object, you will also need to do another API call against that same object to get object tags and specify the object name. And that's where you will get the tags. But unfortunately, it's not possible for you to get that information on a single API call now. You will need to use several API calls.
All right, great. Thanks, Hugo. That's all for right now, so I'll turn it back over to y'all.
Great. So moving forward, access points. So what is access points? Let's say that you have a bucket, and as we talked about, you can grant a bucket policy, but unfortunately, bucket policies has a limitation. So, and that limitation is from 20 kilobytes. That's the maximum amount of policies that you can put on a bucket policy. And if you have a big organization and you need to share a lot with a lot of customers, you can easily reach out that limit. And for example, S3 access points is one way for you to do that. Because with access points, you are able to create policies for each individual access points. And you can very specifically and do a fine grain control against that permission. So for example, what we're seeing here is the IRN of this access point. For you to access your objects through an access point, you will need to use that specific access point. And one of the use cases is exactly this. Let's say that you have a huge data lake and you need to grant permission to your finance to only have access to that finance part, to the accounting, to the sales, to either third-party customers. You can use access points to fine-grain control that so that the finance will only see the finance data, the accounting will only see the accounting, and the sales and the third-party customers will only see their data. And as we saw, so you can easily segment your clients into these different groups, and you have a very fine grain because each access point can have their own policy. So you can only apply what you wish to that specific access point, while other people still have full access or have a more broad access. And of course, it's always on a single point so that you can restrict access and control all of those access points. Next, encryption. Luis, can you tell us a bit about encryption and how can you use it on S3?
Sure, thanks, Hugo. So yeah, with S3, there's two types of encryption. There's encrypting your data in transit, and then also encrypting your data at rest. So encrypting your data at transit is using SSL or TLS, and S3 uses HTTPS by default. So this means that for transferring data or any S3 service requests that issue through the console or S3 APIs, SSL TLS encryption is enabled by default, and there's no manual requirement needed by you. And then for encryption at rest, there's server-side encryption. So server-side encryption is where you request S3 to encrypt the data for you your objects before saving it on disks in our data centers, and then decrypt it when you download the objects. So there's three different types here, which I'll come back to in a second. And then client side is where you encrypt the data on the client side and upload the encrypted data to S3. So if you were to go with this option, you manage the encryption process, the encryption keys, and any tools that you use as well. So just touching on the three different options for server side. Oh, actually, just go back one slide for a second. I just kind of want to delve into this a small bit more. So you have SSE, so server-side encryption, S3 managed keys, which are managed by S3, and the encryption keys are, each object is encrypted with a different key, so S3 manages everything for you. And then we have server-side encryption, KMS, that's our key management service, our encryption service, where you can manage the keys or even provide your own keys if you wish. So this would give you a bit more granular control if you can't decide between the two of them. So KMS would give you more control over your encryption keys because you can actually control who has access to them by creating key policies, for example, which are another type of resource-based policy. And you can define who has access to use the key or administer the key. And also you're also in charge of when the key should be rotated as well. You can control that, whereas S3 managed keys, everything is done for you. And then the other option is customer provided keys. So this is where you provide your own encryption keys. You have full control over them, access to them, key rotation, everything's organized by you. So moving on to the next slide there. So delving it just a bit further into KMS encryption. So there's two different types of keys that you could use to encrypt your data on your S3 bucket. And by the way, only symmetric keys are to be used here as well. That's all that S3 supports for this. So for AWS managed KMS keys, they're fully managed by AWS. They're generated on your behalf, and they only have access to the account that your bucket is in. You don't manage the key policy. This is all done for you. So you don't control who has access to the keys. AWS does this, and it can be disabled or deleted. Whereas customer managed keys, it's a bit more work for you, but obviously it depends on your use case. It's managed by you, so this might actually suit you better in terms of security. Fine-grained access controls, so it has the KMS key policies where you can define who has access to it, as I mentioned before, and you can actually grant different accounts access as well. It doesn't have to just be in your same account. And if you wish, you can disable or delete the key. Well, actually, and you can also rotate the key as well. So you can decide if you want it to be auto-rotated, or you can also rotate it manually on demand. So here is just a diagram of KMS encryption where you are actually enforcing KMS encryption before you upload data to the bucket. So as you can see here, there are temporary credentials generated, and then this has a customer master key here, which is then encrypting the data for your object. And then you are going, once the object is encrypted, then you're going to go upload it to your S3 bucket. And you can actually define in your bucket policy, you can define something that's a condition, for example, where you are enforcing KMS encryption or any type of server-side encryption. and layers of protection for your data. So here are some other ways that you can actually protect your data as well, just different best practices and security features we offer. So first one is versioning. You can enable versioning on your bucket, and this will help you recover from any objects that are accidentally or maliciously deleted or overwritten. So this can be really handy just in case anything important does get deleted, I guess. Then you have object lock, which we'll actually go into more on the compliance side, but this will help you prevent any objects from being deleted or overwritten within a certain period of time, a fixed time, or indefinitely as well, depending on your compliance regulations requirements. MFA delete, so this is multi-factor authentication delete, where you have just an additional layer of authentication, basically. So you have to put in a second layer of authentication before actually being able to delete or override anything in the bucket. And lastly, replication. So this is basically an automatic asynchronous copying of data from your S3 buckets, and it can be done cross-region. So that's C or cross-region replication, or S or same region replication. So this is ensuring that your data is available in another region and just making it more available and I guess more redundant as well. Are there any questions for now from the group, Rob?
Yes, so we do have a few questions additional as well. So one of them from Skolex is here. Is there any way of updating the object owner without an in-place copy?
I can take that one, Luis.
Yeah.
No. So per the S3 ownership model, the account that uploads the object is the account that will own the object. So what happens here is that for you to change the ownership of the object, you will need to copy the object back to himself and using the other account credentials. So it's not possible for you to, without copying the object back to himself, update the ownership. I'm sorry.
Okay, thanks. And then another question here from Princeton Girl 21 is, can I enable encryption with KMS on all existing objects in the bucket after it was created?
I can also take that one.
Yeah, sure.
No. So what happens that when you enable, for example, default encryption on a bucket, that will only be action for all new objects from that moment forward. So you will not let's say backlog all the objects that exist on the bucket. For that, you will need to, as previously, copy the objects back to themselves and either provide the encryption key or just copy the objects and the default encryption will kick in and apply the encryption. One example that you can use, for example, is S3 batch to copy the objects back themselves and so apply the encryption. But from the moment you apply the default encryption, only new objects will get the encryption. The existing ones, they need to be manually processed so that the encryption will be applied.
Great, thanks. We've got one more here today as well from Joe Desmond. That's, which keys would you recommend to use? It gets back to our KMS question or subject before.
Yeah, I'm assuming this is for the encryption keys. So, Joe, it really just depends on your use case and what best suits your security requirements. So whether you need to consider key rotation, how often it needs to be rotated, where your keys need to be stored. It depends how much access control you need as well. Like, do you need to have granular access control, or would you prefer if it was managed for you? So it really just depends on exactly your use case, exactly your security requirements. But if you have a support plan, feel free to reach out to us and we can help you out a bit more specifically.
Thanks, Luis and Hugo. Appreciate it. Back to y'all.
Thank you. So as Luis mentioned, replication. What is this? It's a feature that S3 has. And you can do replica. What happens is that you will configure your buckets so that every time you upload a new object into your bucket, automatically S3 will replicate that object into another bucket. It can be on the same region or it can be on another region. Recently, S3 also launched replica one-to-many. So that means that you can upload an object into that bucket and that bucket will replicate your object into multiple buckets. Until then, you had to manually do it, but now we support that out of the box. how you can, so what are the use cases for this? First, disaster recovery. Let's say that you are doing cross-region and for some reason there is an issue on AWS region. You can easily switch over to the other region and that's it. Latency wise, if you are using a global service and you want to distribute those objects across the globe, you can easily do the replica so that once your client in, let's say, North America uploads an object into your bucket, automatically that object will be replicated in Europe and Asia. So the next time an user in Asia tries to download that same object, instead of need to go to the bucket in North America, now we'll just download it close to him. So you can get much performance and latency wise will be reduced. And what happens also with encryption, in this case, replica, you can also apply encryption. So that means that when you upload an object into your bucket, you can specify which keys you want for those objects to be replicated. And to answer the one question of one of our listeners, while doing a replica, and if it's a cross account, in that case you will also have the possibility to select which account you want the object to be owned. On a normal situation, the account that is pushing the replica will be the owner. But if it's a cross account, like you have a bucket on account A that is replicating into account B, and you upload the object into the bucket on account A, you have the possibility for S3 to, when uploading, in this case, when replicating the object into buckets on the account B, to change the ownership so that the owner will now be account B. That's a possibility also to avoid any cross-account access in the future. Next, we have pre-signed URLs. As we talked earlier, by default, your buckets are private. So S3 will create a bucket for you, and that bucket will be private. You can apply policies like a bucket policy or ACLs to allow those objects to be public. But you can also apply the block public access to be sure that those objects are not public. But in cases where you want to share objects with other users, and without either sharing them your account or granting them access to your bucket through a bucket policy, you can use pre-signed URLs. Basically, a pre-signed URL is going to be a link to that object that was pre-authenticated using your credential. So you have a user, you have a credential on that user, and you will pre-authenticate that. With pre-signed URLs, you can specify how long the URL will be valid. If it's going to be to download an object, if it's going to be to upload an object, you can either generate pre-signed URLs to copy objects between buckets, or even, lastly, to delete an object. Let's say that you want to grant one customer the possibility to delete that object anytime they want. You can also generate a pre-signed URL so that they, on their own, can delete that object. There are only one cautious here, is that pre-signed URLs will be valid until they are expired. So when you create a pre-signed URL, you define what is the expiration date. And on top of that, the pre-signed URL will also be valid until the client or the user that created that pre-signed URL exists. Like, for example, if you have temporary credentials, and you create a pre-signed URL using temporary credentials, when the temporary credentials expire, so does your pre-signed URL. Even if you set expiration in 5 or 6 days in the future, but if the temporary credentials expire in a couple of hours, that's until when your temporary, your pre-signed URL will be valid. One final note, using S3 pre-signed URLs and using an IAM user, the maximum value allowed for pre-signed URLs will be 7 days. It's not possible to extend more than that. Moving forwards, we have access analyzer for S3. So what happened is that we talked about accessing your objects, accessing your buckets, but do we know who is accessing them? No. But with S3 Access Analyzer, you can know that. So pretty much is a basic function that you enable that on your S3 bucket, and S3 will show you who is accessing your objects, who and when is accessing those, which are the objects that are being accessed. So it will continually monitor your buckets and all the access that has been doing, or everybody who's accessing your objects, so that you can easily know who is accessing. And it can also be used, for example, policies that are providing more access than it should be. It's something that you can also find over here. So it's a very highly recommended feature. So how does it work? You have access either through accounts or your organization. On that organization, you have IAM roles, you have S3 bucket policies, you can even have lambdas, KMS keys, SKS that goes that are triggered by S3 events. The analyzer will check all the access that is being done. Every time you try to access something, it will authenticate against your IAM user using your access key and your secret key. And that will be tracked through IAM on AWS. So what happens is that everything will be tracked. And on a single point, you can know exactly who is accessing, what is being accessed, and by who and when at which time. And it provides a highly level of security assurance that you know that no one is accessing anything that it shouldn't be. So it's a single place where you can monitor all of that instead of going to S3 logs, instead of going through either, let's say, Lambda logs, IAM, everything else. No, you can easily get that. Moving forward, we have logging and monitoring. Louise, do you want to talk a bit about this?
Sure, thank you, Hugo. So these are the different types of security logging and monitoring features that S3 offers, just on the next slide. So the first one is CloudTrail. So this would log all API activity in your account at bucket level, and you can also enable it at object level as well. Then you also have S3 server access logs, which is another way to log detailed records about the requests made to your buckets. So between these two services, you can get a very good idea of your customer base, the requests made, your S3 billing, and also security and access audits as well. Bucket access control view in S3. So this is just in the S3 console, you can see who has access to your bucket in just a nice kind of UI. So that's another way you can just check the control, the access control. AWS Trusted Advisor. So this is a really handy free of charge service that we offer, which offers real-time guidance to help you provision your resources in terms of the AWS best practices. So this is for reducing your overall costs, improving performance, and of course security as well, improving security. So for example, we have a bucket permission check, which checks it identifies any S3 buckets that are publicly accessible due to ACLs or policies in your account, and you can be notified of this, and you can then change it if it's not what you expected. IAM Access Analyzer, which Hugo just touched on, so I won't spend long at it, but it just helps you identify any S3 buckets in your organization or accounts that were shared with an external entity, basically. Config rules. So config is our compliance service where you can, one of our compliance services, where you can actually monitor configuration changes to any of your resources, and you can set up config rules and make sure that they're compliant. And if they ever go into a non-compliant state from what you expected, you can be notified of this or set up auto remediation. We'll go into more on this on the next slide. And then lastly, Amazon Macy. So this will scan and give you a full inventory of your S3 buckets to categorize the data, showing any different sensitive data types, including personally identifiable information, PII. So let's say customer names or credit card numbers, or making sure that you adhere to different compliance requirements such as GDPR or HIPAA. Oh, and you can also use it to check if any buckets are unencrypted or publicly accessible or shared with any accounts outside of your organization. This will allow you to quickly address any unintended settings on your bucket. So it's kind of a preventative control, basically. So on the next slide, we'll talk about config specifically. So what happens here is your resources can be changed due to just different users in your account making different modifications to your S3 objects or buckets. then these will be recorded by config, and you can have predefined rules which are managed by AWS or custom rules that you can create and manage yourself. And these can check that your resources are still compliant with the rules that you've set for your account. And if they're not for any reason, you can set up notifications to notify you of this, or even auto remediate whatever it is. So just some examples of the many different config rules we have for S3. So the first one is checking whether logging is enabled for your S3 buckets. So you can set this predefined rule that was created by AWS for your account, and if any bucket is created without having any, we'll say, CloudTrail logging enabled, this rule will turn to non-compliant and you'll be notified of this. Another is checking whether buckets have policies that require requests to use SSL. So that's another predefined rule we have, making sure all requests go over HTTPS. Checking whether S3 buckets are encrypted with KMS. So that's the encryption service we talked about earlier. You can actually have a rule for this, and if any bucket is not encrypted with KMS, again, you can get emails about this, or you can have some auto remediation set up. And lastly, checking whether versioning or MFA and MFA is enabled for your buckets as well for data protection. So they're just some of the rules that we offer. So moving on to S3 compliance. So so the security and compliance of S3 is assessed by third-party auditors, and these audit reports are all available to you publicly in our compliance service, AWS Artifact. So this is another free of charge service that we offer, and it's a place that has all of your, it's like a go-to service for all compliance related information. You can actually download audits and different compliance reports and check your own configurations against them to make sure that you adhere to them. We also have a dedicated compliance team, which you can fill out a form and reach out to them specifically if you have any questions. Then one of the features that we offer to do with S3 compliance, sorry, the lights are automatic, 2 seconds. There. So one of the features that we have for compliance is S3 object lock. So this is basically what I mentioned earlier. It prevents any objects from being deleted or overwritten for a fixed amount of time or indefinitely. So this can actually help with compliance requirements, because if you have, let's say, financial service regulators, they might require you to have a write once, read many worm data model. So that certain types of data or records or books are kept for a fixed amount of time. So this can be done for just auditing purposes, compliance, or maybe just for data protection. So these are some of the features that offers. And if you go to the next slide, you'll see that there's 2 different modes for protection. So compliance mode and governance mode. So compliance mode is intended for compliance, and it does not let anyone in the account delete the data that is in compliance mode, including the root user. And yeah, this is assessed by a third party. And then governance mode, this is intended for data protection, as I kind of mentioned earlier. So you can actually set an IAM permission to allow users to actually modify the data if needed, but it's mainly for data protection to prevent any accidental or malicious deletes or overwrites. Do we have any questions at the moment?
No, thanks. We don't actually have any that are not getting answered right now in the chat, so thanks, Luis. Appreciate you guys. Okay, carry on.
Okay, so moving on to some AWS support best practices. Just kind of summarizing up what we discussed earlier. So the first is, as Hugo mentioned earlier, enabling account level block public access. So this is to prevent any buckets from being publicly accessible, and this can also be enabled on bucket level. However, we usually would recommend account level, because this means that any future buckets that are going to be created will also have block public access enabled as well. Another is implement least privilege access. So this would go back to what I was saying about access controls, granting the least amount of permissions required for any user or role to carry out a task. And this can be defined with identity policies such as IAM, bucket policies with S3, access control lists, service control policies, the KMS key policies, the list kind of goes on. So that's something definitely to implement.
Following on that, as we mentioned, secure traffic. So Luis talked about encryption data in transit. But if we don't want to use the public internet and we have a private VPC, we can use VPC endpoints. We have the gateway and we have the interface. Each one of them have their own benefits. We also talked about access points. If you want to have a fine-grained control on who access your data, if you want to share your buckets, your data across multiple users, different groups, different areas on your organization, you can use access points to do that. And on top of that, even we have the encryption, and it's a best practice to encrypt everything. And while encrypting, you can use the SSE KMS that will give you either the AWS managed KMS or the custom managed KMS. Each of them have their own pros and cons. And lastly, you have the SSE S3. So this encryption is all managed by S3 on its own. You don't have the KMS. It's again, it will provide you more possibilities of controlling your objects rather than the KMS.
And as well as encryption, there's also data protection. So enabling object lock, versioning, or MFA are all different ways to prevent any accidental deletions or overwrites, as I mentioned earlier. So that's whether you're wanting to lock the data for compliance reasons, add extra versions of the same data, or have MFA deletes. That's requiring an extra layer of authentication when you have to go to delete or overwrite an object. And monitoring as well. So using services that are integrated with S3, for example, CloudTrail, which logs all APIs in the account, any API requests, and also config, which will monitor any configuration changes made to your resources. So that's something to implement if you were to consider logging and monitoring your data.
And on top of that, you can also use the S3 server access logs or AWS CloudTrail data events. Like Luis talked, you have the CloudTrail. By default, that's enabled on your account and will record all API level, bucket level APIs. If you want to know who is accessing your objects, who is downloading your objects, or who is uploading your objects, you will need to use either S3 server logs or the CloudTrail data events. On CloudTrail, you will need to enable this because by default, only the bucket level are recorded. This is a service that will have an extra cost, but will record much more information than the S3 server access logs. And finally, we have the AWS Trust Advisor to inspect your Amazon implementation. Like Luis mentioned, let's say that you want to track who if your bucket has a public read bucket policy, if you have SSL enforced, all of those security best practice you can use, and you can rely on Trust Advisor to inspect that configuration on your account, and if it's not implemented, we'll alert you and we'll recommend you to enable that. Moving forward, we have a quick demo, but before that, is there any questions?
Hi, Hugo, thanks. Down on S3 right now, we have one on config that I'm working on trying to find some info for, but I think right now looks like we don't. So if anyone has any other questions on the comments of S3 and the different security features and such, please feel free to put them in the chat here. I'll try to get them answered for you. Thanks all. Thank you.
Okay. So moving forward on this demo, we will go through create a bucket, apply a bucket policy, and encryption and versioning. So let's start. When we go to S3, we will create a bucket. Remember, buckets are, S3 is a global service regarding the bucket name. So you cannot use the same bucket name on different regions, but your data will be stored on a single region. So that's why when you create a bucket, you select which is the region where you want the bucket to be stored. Next, you have the block public access, like we mentioned, but we will go a bit more on that. The next feature is the versioning that will enable different versions. And an advanced setting is the object block. But again, we will go back, we will go on that a bit further. So let's go and create our buckets. we have our bucket created, and as you can see, by default, my bucket is private. No access is granted to the bucket. So this bucket now resides on that region where I select, and I don't have any objects on it. Let's go and talk a bit about the permissions. Block public access. Again, it's not public, it's private. By default, S3 will always create a private bucket. You need to explicitly allow access. When you allow access and you want to be sure that you are not granting anything else more than you want, you can enable the block public access. This is a bucket level or account level feature. Here you can control individually if you want to only apply to the ACLs, new ACLs, existing ACLs, or private or to the bucket level. And here on our left, we can see that there is account level. So the changes that I apply here will be applied for all the buckets that exist on my account, the existing ones and all new buckets that I will be creating. So let's say that we have the block public access enabled, and I'm going to apply a bucket policy. So I will edit and I will apply. Let's use, for example, public reads policy from the examples that we have on AWS. So let's copy this and move back to our buckets. So pretty much I'm granting everybody on the internet get object, and let me just change my bucket name. Okay, so my bucket policy is there, and now I try to save. What happens? I'm getting an access denied. Why? Because I have the block public access enabled. So that means that S3 is not allowing me to create a public read bucket policy because it's there. I'm clearly saying that, hey, I don't want you to allow that. The same goes with ACLs. If I try to create an ACL that allows everyone on the internet to either list or read my buckets, because the feature is enabled, account level or bucket level, S3 will deny me that operation. So I will not be able to create that. So keep in mind, this feature is very useful if you want to be sure that no one by mistake creates a public read either ACL or bucket policy, and by this allowing you to access objects that you shouldn't be want. The next is server access logs, like we talked. The server access logs, this is per bucket, so that means that I will be enabled on the bucket level. I will go into my buckets, I select where is the destination for my logs, so where my logs will be stored, and I save. One recommendation is to create one bucket only for logging. So it's not recommended for you to use the same buckets that you are logging to be the destination of your logs. So you should always create a bucket only specific for the logs. Next, we also have the CloudTrail data events. As you can see, it's disabled. If I want to CloudTrail to also record my object level, like the gets, the puts, the deletes, I will need to come here and enable that feature because by default, it's not. Okay, moving forward. And another protection is bucket versioning. By default, every time I upload an object, and if I delete or override, that object is gone. When I enable bucket versioning, pretty much I'm telling S3 that, hey, if I delete an object or if I override or I upload a new object with the same name, I don't want you to override. I don't want you to delete. S3 will create a new version for that. So let's say, for example, if I upload an object into my bucket that is not versioning enabled. As you can see, versioning is disabled. Okay, pretty good. I upload the object is now on my bucket. If I perform an operation like, for example, delete that object, as you can see, S3 is now asking me to confirm if I want to delete, and notice the permanently delete. I need to type, yes, I confirm that, and that's it. My object is gone. Please keep in mind, every time you delete an object from an S3 bucket, there is no way for you to recover unless you have versioning enabled. Now that my bucket is versioning enabled, what happens is that once I upload my object, S3 will, okay, create that object, but now we'll create a version. And if I check on my list, and if I try to delete, perform the same, if you realize now it's only delete, it doesn't ask me to permanently delete. The object is gone. But on my listing, if I list versions, if I enable this option, S3 will list all the versions that I have on my bucket. And as you can see, I have the current version that is just a delete marker. It's just a pointer saying that this object is deleted, and I have my previous version. If I delete that delete marker, that pointer saying that, hey, this object is delete, voila, my object starts, goes back to show. So if I disable the list versions, I will see my object again, because that pointer no longer exists, and S3 will treat my previous version as the current version. So my old object will now become the current version. Next, we have the default encryption. By default, my objects are not encrypted unless I enable this, or on the upload I specify. And when we enable this, we have two options. We can either use the Amazon S3 keys, or we can use the KMS. In this example, let's use the S3 SSE. It's simpler, as we don't need to perform any KMS. So as you can see, the object that we uploaded earlier, and when we check the encryption, there is no encryption. Now, what happens is that I have default encryption enabled. Now I'm uploading a new object. As you can see, S3 now is telling me that default encryption is enabled. I could, of course, select other types of encryption if I wanted, but if I'm not, then S3 will apply the default. Again, S3 will only apply the default if on my uploads I'm not specifying any encryption. My object is now uploaded. Remember that I have version enabled, so let's list the different versions. And my previous version, in this case, my current version, now has S3 encryption, and is using the encryption type that I selected, the S3 SSE. If I check my objects, again, remember that it's not possible for me to go back and encrypt all the objects. My bucket is now private, and I want to grant access to this object. As we also talked about S3 pre-signed URLs, I can create a pre-signed URL. There are several tools. AWS CLI allows that out of the box. I just need to have the CLI configured. So what I'm going to do is I'm going to create a pre-signed URL. I specify which is the bucket and the key, and I can also specify how long the pre-signed URL is valid. And the CLI will return the pre-signed URL. So this is my pre-signed URL that I can share with all the users, and the users will now be able to download this object. Even so, my bucket is private, and I have the block public access enabled. But that pre-signed URL automatically authenticates for me to download this object. Okay, moving forwards. And lastly, object locking. Object locking, we need to be aware that this must be enabled every time that I create a bucket. If I try to enable this after my bucket is created, I will not have that option. And the only way for me to enable this is to reach out to AWS support so that they can give us a special token that will allow me to enable the object locking. So be aware, every time you create a bucket, if you intend to have that, you should enable from the start. Okay, and that's the end for our demo. Not sure if we have any questions. Rob?
Thanks, Hugo. Do have one question real quickly here if you have time for it. From Casimir D, they've been looking at doing some pre-signed URL, but getting access denied with an IAM role that's trying to access it. Just see if you had any tips from just the demo that you had there quickly on that info.
Sure. So when you create a pre-signed URL, you need to be sure that the user that is generating that pre-signed URL, so the credentials that you are using to generate that pre-signed URL, has access to the bucket, has access to the object. If the object is encrypted, that user, and in this case KMS, the user also needs to have access to the KMS. You need to check that. If everything matches, what you can also do is one thing is was your bucket created recently? Because when you generate a pre-signed URL, S3, so the signing method will also sign the host. In this case, the bucket name .s3.amazonaws.com. But if your bucket is very new, usually it takes 1 or 2 hours. What happens is that your the endpoint, that global endpoint, the bucket name .s3.amazonaws.com will point to North Virginia. That's our global region. And then S3 will say, hey, that bucket is not on North Virginia, it's on the other region, and will automatically redirect you to the region where the bucket is. And you might get an access denied, or the common error is also the signature didn't match exactly because of that. So I will say, if the bucket is new, wait a bit more until the DNS is propagating. If it's already an old object, then yes, you should confirm that the IAM user has the proper permissions to access that object, that the object is if the object is encrypted using KMS or not, and again confirm. One thing what you can do is using the normal CLI, like S3 API, head object, and go to that object. If you have access, okay, then probably it's that redirection because of the bucket is still new. Hope that answers the question.
Rob, I think you're on mute there.
Thanks, Luis. Appreciate that. Everyone, today we looked at S3 best practices in security. If there's any questions that were not answered today, you can post your questions on the AWS forums at forums.aws.amazon.com. And feel free to email us any feedback to awssupportsyou@amazon.com. We want to hear from you and tell us what else you would like to see on this show. Thanks for joining us on AWS Supports You. Happy cloud computing.